Hi, my name is Max Gerhak. I'm a co-chair of the International Color Consortium, and today I'm going to talk about wide gamut and HDR with ICC MAX color management. To start off with, I'd like to compare basically the differences between how the ITU goes about color management and the International Color Consortium. With the ITU, it basically uses a method that defines what a pixel is. The ITU defines an explicit definition of a pixel encoding, which contains the number of bits, the number of samples, the sampling order, bit formatting. And it has implied transforms. And basically any system that wants to use this has to understand the encoding values and then has to understand and do the right thing to make the conversions that are needed. The changes in identifiers will potentially require changes in the system itself, and each system needs to input the same transform to get interoperable results. Contrasting that to is the way ICC approaches things. Is ICC uses the appearance of a pixel, and ICC profile is abstracted away from the pixel encoding. Pixel encoding is a separate part of the CMM programming interface, and integer samples are mapped from a range of 0 to 1 by the CMM, and floating point values get passed straight into the profile. And a significant difference is that ICC defines transforms from the device to the colorimetry using a profile connection space, and PCS to device. The PCS defines the appearance, and HDR-based PCS is needed to do HDR color management, and the CMM, it simply applies the transforms to find the profile. And what this really means is that if you really want to have different kind of transforms, you basically put what you need into the transform, and it doesn't require CMM or system changes. The ICC is in the process of putting a proposal together to put ITU encoding identifiers into a CICT tag. Now, as I mentioned before, a HDR-friendly profile connection space is needed. Now, the ICC color management uses relative colorimetry for relative, perceptual, and saturation intents. What this really means is the white points map to one another to provide interoperability, taking advantage of the adaptation of the human visual system. With HDR, we need to have the idea of kind of a relative HDR. The idea there would be to have a media white point colorimetry that corresponds to HDR graphics white, while the peak white maps to colorimetric values that are above the media white. This would result in a relative SDR white point mapping to HDR graphics white, so it would be interoperable with existing legacy ICC color management, and this is suitable for HDL encoding. However, in some instances, luminance-based HDR would be desirable, and ICC MAX profiles contain or assume the luminance for the media white point, and therefore media luminance matching is performed in the CMM by scaling the luminance points of the connected profiles, and this would be required for something like PQ encoding. Note that when we're connecting profiles together, tone mapping and gamma mapping can conceptually be done in abstract profiles within an HDR-friendly PCS. This is something that the ICC is currently working on. Benefits of ICC MAX. People understand ICC color management, but for wide gamut and HDR color management, I see that there's three specific areas where it can be a benefit. First of all transforms are based on floating point. The PCS encoding uses the entire floating point range. Floating point device values can utilize the entire floating point range as well. An example would be that you could have a floating point based sRGB profile that could map to wide gamut and HDR PCS, where the values between 0 and 1 correspond to normal sRGB, and values that go outside that range would map to HDR PCS's values that go outside that range. Second of all, ICC MAX provides a flexible definition of PCS colorimetry. You have an arbitrary choice of a luminant observer with pluggable transforms to get to the standard PCS colorimetry. This means that the PCS can be D65, which was used in displays. Additional custom observer color matching function can be supported for people who are deviant or even slightly different. This is especially important when the primaries on displays become very narrow. Lastly, ICC MAX provides flexible transform encoding with arbitrary sequences of various processing elements, with curves, matrices, lookup tables, etc. And it also potentially has a stack-based calculated element where you can basically directly encode arbitrary functions and have CM environment variables that provide parameters for functions. This would provide means of actually putting things in like the ambient luminance or other factors that may actually want to configure how a profile works without necessarily having to have a custom system. With ICC MAX, the ISO 20677, which is the standard defines ICC MAX, it encompasses an extremely large set of color management possibilities. And an interoperability conformance specification document provides the means of defining limited subsets of ICC MAX for specific workflows and use cases. This provides for a basis for standardizing narrow color management workflows using ICC MAX. Basically, an ICS defines or provides header contents, required elements in their contents, optional elements in their contents, and workflow description, including connections to color spaces and other profiles, and example profiles that conform to the ICS. Core ICS documents have recently been approved by the ICC, being colorimetric, spectral reflectance, extended output, and extended range. And the website link there gives a where you can get to those documents. Other organizations can define ICSs and register them with the ICC. Lastly, those three areas that I see as advantages of ICC MAX are applicable in the extended range display and color space ICS that was recently approved. This provides a multi-set part of specifications that are potentially useful for wide gamut and HDR color management, and these three parts really basically align with those things. First of all, part 1 gives basic encoding. This limits the transforms to curves, matrices, and ND lookup processing elements with a floating point encoding using an HDR PCS with D50 colorimetry for the standard 2-degree observer. This is basically it guarantees the ability to get into an HDR PCS without necessarily having a large overhead over what can be done with legacy version 4 profiles. In addition to that, Part 2 allows for custom PCS to define with the same processing elements. However, the PCS can support arbitrary illuminant and observer color matching. And the third part basically takes into account the fuller, rich set of the processing elements with the ability to do spectral modeling of displays and a calculated element for functional modeling. And the HDR PCS with arbitrary observer and illuminant is possible for that space. And that's all I have. Thank you very much.